I'm good, Ryan. Thanks. So, hi. Brent already talked about this, so I'll skip over most of it. Jamison.dance. Thank you. I do a podcast called JavaScript Jabber where we talk to smart people about cool things they build in JavaScript. I'm Jurgensen on Twitter, React Rally. And because there are a few things that make dads happier than forcing groups of strangers to look at pictures of their babies, here's my baby. Thank you, thank you. That's the correct response. I appreciate that. I want to step up on a soapbox very briefly and talk about the word isomorphic. This is the Wikipedia page for isomorphic. It's got a lot of words, so we'll zoom in on some essential parts. For most algebraic structures, including groups and rings, a homomorphism is an isomorphism if and only if it is bijective. Now, I don't know what any of those words mean. I just highlighted stuff at random. But I know what they don't mean, which is server-rendered JavaScript. So I just want to, in a spirit of love, suggest that we not use the word isomorphic to describe server-rendered JavaScript. That'd kind of be like me making a library that replaces all the images on a website with pictures of my face and calling that React.js. Like, that name is taken already by a different thing. So let's I don't know, server-rendered universal. Let's use one of those. OK, off the soapbox. I want to talk a little bit about the rise in the size of JavaScript applications. This is a graph showing the average JavaScript payload from 2010 to 2015. It's a little hard to read, but it says that the average size has gone from 100 kilobytes to about 360 kilobytes. So it's more than tripled. And I think this reflects the growing richness of experiences that people are building in JavaScript. They're sending more JavaScript down to the client to do more things. Interestingly, if you extrapolate from this, in 2047, we'll download a petabyte of JavaScript. So prepare your Webpack loaders for this reality. I think that last talk will actually help a lot with this. So in response to this, larger applications being built in JavaScript. The JavaScript community is amazing. They build all these cool tools. GWT came out in 2006, I think. It was a Google effort to write in Java and transpile to JavaScript. It's an attempt to answer the question of how do we build these large, complex applications. Don't use it anymore, though. Require.js was an early kind of module loader. I think it was 2009. Backbone, or sorry, this is the Google Closure compiler. It was 2009 as well. And it also did some module bundling and minification and concatenation and some type checking as well. Angular, I think the first commit was either December 31st, 1969, or sometime in 2010. They might have some date bug going on in their Git history. Backbone was actually after Angular. It was also 2010. And then Ember was, I think, 2011, React 2013. And then all these other tools to help. There's Webpack and NPM and Grunt and Gulp and Browserify and Babel and ES6. But the underlying substrate of all of these tools, the underlying assumption is JavaScript, right? The assumption is you are building web applications in JavaScript. How many of you have heard of this phrase, rethinking best practices? OK, lots of you. Shout out to Pete. He's somewhere around here. This is from a talk he gave introducing React in 2013. And I love this phrase because the first time you hear it, it kind of sounds like the ramblings of like a stoned out teenager in his bedroom. Like, what if we replaced all the semicolons with monkeys? But that's not the idea. The idea is actually, because you do something, that doesn't mean that's the best way to do it. That's just the way you do it. If you examine some underlying assumptions, you might come up with a better approach. And that's what React did. And people thought it was not good. And they were wrong. It is good. And in that spirit of rethinking best practices, I want to talk about the Elm programming language. How many of you have heard of Elm? A lot of people. Cool. How many of you have used Elm at all, like written any lines of Elm code? OK, fewer people, but still some. Awesome. So Elm is a functional programming language that runs in the browser. It's not JavaScript. It transpiles to JavaScript. And this isn't a talk about how to write Elm applications. I don't think I can teach you in half an hour how to actually go out and build an Elm app. This is why you should look at Elm for writing applications, why you should teach yourself. So to do that, we're going to look at some problems that we encounter in JavaScript. This was from Texas JavaScript in 2013. They actually put up on the marquee of the theater, undefined is not a function, because that's like the most JavaScript phrase you can think of. How many of you have had runtime errors in your JavaScript? I see some hands not going up, and I want to talk to you. Yeah, or someone shout out liars, but I didn't say that. Yeah, this is a problem. This happens all the time in JavaScript. This is a dumb function. Like, you can clearly tell this is going to throw an exception. This is a stand-in for more complex code where the error is hidden deeper, but that won't fit on a slide. So here's our example. You call this function foo, you pass in a number. If the number is greater than 10, it returns a string. Otherwise, it implicitly evaluates to undefined. And then you call to uppercase on the result. And if you pass in a number less than 10, it'll explode, because you can't call to uppercase on a string. Or on undefined, I'm sorry. And there are a couple different solutions to this problem that the JavaScript community has come up with. There's one class of solutions that's kind of the know when these errors happen. And there are services like Track.js and Sentry and Raygun and a bunch of other ones. None of these people gave me money, by the way. They were just the easiest logos to find. They'll aggregate your client-side errors in some service that you can then look through and figure out where they came from. There's also the awesome Chrome developer tools. These are really great tools that will help you write better code, and I recommend them. But I'm a little sad that I live in a world where someone can make a career out of tracking errors that happen in your code, because it means they happen so much. It's a little bit like you have a house, and it's a really ugly-looking house, actually, when it's blown up on the big screen. But it's a nice house. It's our house. We like it. And then it lights on fire. And someone comes and tells you, hey, Bob lit this house on fire. And you're of two minds at this point. One part of you is like, thank you, now I can go have a conversation with Bob and figure out what's going on here. But the other part is like, ideally my house would not be on fire right now, and you wouldn't have to tell me anything. And that's kind of the other class of JavaScript tools that I want to talk about, which prevent errors. This is stuff like ESLint, which does some style checking. It can also catch some like misspellings of variables or things like that. And there's also tools like Flow. It's been brought up a lot, and we'll talk about it more. Flow is awesome. Flow adds a gradual type system to JavaScript, and it can do sophisticated analysis of how values flow through your program to detect errors. Here's that same function we showed earlier as a reminder, and let's see what happens when we run Flow on it. So Flow tells us, call of method to uppercase cannot be called on possibly undefined value. That's awesome. Flow detected that sometimes this function will return undefined, and if you call to uppercase on undefined, it breaks. So Flow yells at us, job done. We can fix this bug, and our lives are better. Except there's one thing that gradual type systems do. It's a design decision. You can turn them off on individual lines or functions or files. That's because they were designed to run on existing JavaScript code bases. And there's some ways that people write JavaScript that are just hard to run through a type checker. So it allows you to gradually add flow over time to your project. And it's a good feature. So this is Flow syntax added to this function. That :any after the closing paren tells Flow this function can return anything. You can make no assumptions about it. It's basically like, go away, Flow, I know what I'm doing. And here's what happens when you run Flow on this code now. No errors. Well, there are still errors in this function. And this gets to, I think, an essential weakness in gradual type systems. They're awesome tools, but the fact that you can turn them off when you get frustrated, or when you get stuck, or when there's a deadline, or if you're new on the project and you don't quite understand how the tool works, or you're just having a bad day, that means that you will turn them off sometime. And then you'll lose that safety that these tools give you. There's another issue with them, which is related to this, which is code that's hard to type check is code that you're not going to type check. And that code is often the tricky, important parts of your application that you most need to type check. Because there's an out clause, you'll use it because you're a human and you're subject to human failings. So let's talk a little bit about Elm now. It's been 10 minutes, and now it's time to talk about Elm. Elm has a static type system. And one consequence of that is you get no runtime errors in Elm. This is hard to explain in words how awesome it is, so I'm just going to make this text bigger. No runtime errors. And you can't opt out of the type system, which means that Elm can make very strong guarantees about how your code works. Let's look at some examples of how this looks. So this is Elm code. This is a function, foo. It takes in an argument num. So everything after the equal sign is the function body. And we're trying to rewrite the same function we wrote in JavaScript, but in Elm. So if num is greater than 10, then we return some string. In Elm, the returns are kind of implicit, so you don't have to type return. Let's see what happens when we run Elm on this code. Oh, it's a compiler error. I ran into something unexpected. I was looking for one of the following things in else branch. OK, so we forgot an else. You need to have an else. You can't have an if without it. Put that in. If num is greater than 10, return a string. Otherwise, null. Oh, there's no such thing as null in Elm. Sorry. Wow. I didn't expect applause there. Great. I agree. Here's the error that it gives you when you do this. Can't find variable null. And then I love how helpful it's trying to be. Like, did you mean num or list.all? Like, oh, Elm, you're trying so hard, but I did not mean either of those things. Thank you for trying, though. So let's write this in a way that works. So we have to return something. We can just return a string in the else block. And now this function will compile. Our program will not break. That's probably more important than this compiling. We won't have a runtime error. But this isn't the same behavior as what we had in JavaScript. In JavaScript, we either returned a string or we returned nothing. And I want to talk a little bit about how Elm's type system can help enforce this behavior. But to do that, we have to talk a little bit about the type system itself. So here's how you define a type in Elm. This is saying create a type named bool, and the possible values this type can take are either true or false. There's nothing special about the word bool or true or false here. These are just names you give to either the type itself or the values the type can take. This is actually how a Boolean is defined in Elm. It's just a type in the Elm language. It's not built into the compiler or anything. Here's another type that's a little more complex called maybe. And a maybe type kind of represents something that can either be empty or have a value of a certain type. So maybe a, that lowercase a, is a stand-in for another type. So a maybe of some type can either be just a value of that type or it can be nothing. And we'll show how it's used. This is how you do it. If number is greater than 10, then just the string, otherwise nothing. And now the compiler can run on this code, and it can help us make sure that we check all the cases, and we're not going to get nothing when we expect just and stuff like that. So as an aside, Elm has types, but you don't have to write the types out on your functions. It can figure them all out. If you want to, this is how you do it. The function name, and then the colon, and then the argument, and then that's the result. So this function takes an int. It returns a maybe string. Here's how you would use it. This is another function, bar. It calls foo and then runs a case statement on the result. So it checks if we get a just string back from foo, then call to uppercase on it. Otherwise, return the string whelp. And the cool thing to notice here is if we leave off that nothing check, then the compiler will yell at us. The case does not have branches for all possibilities. You need to account for the following values, maybe dot nothing. So the Elm knows all of the possible values that the type maybe can have. And it knows when you're checking some of those and not all of them. And this is awesome. Think of this in like a Redux app, right? You have all these types, these action types that you can have. What if you had a compiler that checked if you were misspelling one of these, or checked that you didn't handle a certain action type in your code? It's pretty great. So what would a React conference talk be without a Dijkstra quote? The competent programmer is fully aware of the strictly limited size of their own skull. I want my computer to do things that it can do well, so I can do things that I can do well. And the computer is much better at tracing the flow of values through a program than I am. I'm not going to think of all the edge cases. I'm just going to think of the happy path, because that makes me feel better about my code. I don't want to break my code. I don't want to know if it's broken, because that means I'm a bad programmer. But the computer has no mercy, right? The compiler will tell you, and then you'll fix it, and you won't have these errors. I need my brain space anyways to do something else, which is work on my startup, Uber for Cats for Dogs, which is serving the underserved dog-manned economy by delivering cats to them. We're looking for our first developer. if you're interested, we're actually not looking for a designer. As you can see, design is on lock. So yeah. All right, I want to talk about another problem that happens sometimes in JavaScript, which is as applications grow, often they become harder to maintain. They get a little tangled. They're harder to add features to. They can get harder to debug, easier to break. I know that sometimes when I'm writing code, I just have this feeling that I don't know why, but I'm pretty sure in 6 months I'm going to hate the thing I'm doing right now. And the JavaScript community, because it's great, has lots of solutions to this. One solution is React. And React is awesome. I love React. I've been doing React for a few years, and I think it's a great tool. With React, you structure your app as a tree, components, right? You all know this. Pass data down, and then when things happen, you somehow pass stuff back up and then re-render the application. This is a great pattern. And you can build applications like this in JavaScript. But you don't have to. You can do whatever you want. You could build a library that searches Stack Overflow for keywords, so you type drop-down menu, and then it finds the JavaScript code that in the post for drop-down menu, and then like evaluates that on the page, and build an application out of that. And nothing will stop you in JavaScript, except maybe your conscience. That'd be a cool library, by the way. If someone wants to write that, I would use it. In jest only. So the point is there are patterns in JavaScript, but nothing's forcing you to use them. So the React model is such a good idea that Elm actually looks very similar. The way you build applications in Elm is you have this tree of functions. You pass data down to child functions, and it renders out some UI. And then when some user interaction happens, you send data back up to the top. There's a top-level app state. You update the app state, and then you re-render the application. The difference is this is the way you build applications in Elm. This is the kind of accepted pattern. All of the community documentation, all of the core libraries is built around this pattern. So when you come into Elm, there's a lot of new stuff to learn, right? It's a new language. It's got new syntax. But you don't have to decide, how do I build stuff? Because that is already decided for you in a good way. And I think that's pretty powerful. Let's talk about another cool thing that's happening in JavaScript to help solve kind of issues with maintainability. How many of you have heard of stateless functions? A few hands. You might have heard of them called pure functions. Can anybody give me a definition of what a stateless or pure function is?
No side effects.
No side effects. OK, if you want to come up, give the rest of the presentation, because that was a really good answer. Yeah, no side effects. A stateless function just takes in input, and it returns output, and the output only depends on the input. This is a good way to build applications, because stateless functions are easier to test. You can just run them. You pass values in and assert on the results. They're easier to reuse in other places because they don't have dependencies. You don't have to mock anything out or set up complex layers of dependencies to reuse them. And it lets you build more composable and maintainable applications. So you can do this in JavaScript. This is a stateless function that adds two numbers, return a plus b. Great, it works. But you don't have to. You can do whatever you want in JavaScript. Nothing is stopping you from writing this. Fire the missiles, and then add the two numbers. And let's look at what that looks like. I wrote this function, but I'm not quite sure what's happening. I mean, 1 plus 3 is 4. 5 plus 8 is 13. So things look OK so far, but there's something weird going on. So let's write this for loop and kind of check out the results. Oh, it turns out I don't know how to write for loops. Just call it a bunch and see if we can figure out what's going on that we don't understand. So we'll add the loop index together. And I have good news and bad news. The good news is that 99 plus 99 is 198. The bad news is the world has ended. All that remains of our shattered society are a few faded Uber for cats for dogs billboards to remind us of what we once had. So yeah, you won't do that. You won't fire the missiles in your add function. But you might do something that looks more like this. Say you want to track for analytics purposes, like marketing, big data, I don't know, buzzwords. Every time a user calls the add function, you could put in this function to record user addition. And it's going to send a request to some third-party service, and then you're going to big data your way to the cloud and all that stuff. And that's really convenient, right? Nothing in JavaScript is stopping you from doing this. But now you've destroyed the stateless nature of the function. Now you have to set up dependencies to reuse it in other places. Now you can't test it as easily because it's going to do this other thing when you call it. And yeah, so you can do this in JavaScript, but it might not be best for the long-term maintainability of your project. So Elm only has stateless functions. This is the way you write functions in Elm. There's really only way to write the add function. You can add two numbers, add A and B. That's, I mean, yeah, you can see it. There you go. The Elm type system will actually enforce this. If you try and do a side effect inside of a function, it'll yell at you. Your program won't compile. So by making this decision for you, Elm is encouraging you to build applications in a way that's better in the long term. Let's talk about immutable data. How many of you know what immutable data is? It's come up a few times in the conference already. If any of you don't, the idea is that if you have some data structure, you don't modify it in place ever. You return a copy with those modifications applied. And there are libraries to do this in JavaScript. There's Immutable.js that Lee Byron, who's somewhere around here, wrote, and it's rad. There's Mori. There's a couple other ones. You can do it in pure JavaScript as well. Thank you, Sebastian, for letting us use the object spread operator, I think it's called. So update user score will take in a user and some points. And then this will return a new object with all of the properties of user plus this updated points property. So you can do this in JavaScript, but you don't have to. Look at how much shorter it is to not do that, right? Like, it's like the language is encouraging you to just mutate it in place. And maybe you don't know, too. Like, everyone is learning. Everyone's coming in at a different level. And there's a lot of stuff to learn. So the fact that you need to learn, hey, immutability makes my applications better, means that you might not know that at some point. Oh, yeah, this. Like, immutability is better for you. Vegetables are good for you. Sometimes you just don't want to eat your vegetables, too. Elm only has immutable data. Immutable data structures are built into Elm, and they're the only way you can interact with data. So here's how you would write that update user function in Elm. Update user takes in a user and some points. And then this syntax is just how you say modify this object. Take the user object, set its points field to this new value, and return that new object. So this is another case where Elm has these good ideas built in at the language level. Let's talk about one more issue that's come up in a couple talks already, which is, yeah, React tells you to structure your app as this tree of components. But this part right here, it doesn't really tell you that much. How do you actually get the modifications back into your app, right? How do you communicate state around your application? And again, the JavaScript community is smart, and they have lots of good ideas about this. There's callbacks, there's Flux, there's Redux, there's observables. We learned about some ClojureScript stuff that I forgot already. But there's lots of really cool ideas about how to do it. But they all have different trade-offs, and they also have the issue that you need to decide between each of these and learn it and figure out why it's better for your needs. So in Elm, the way you communicate state around your application is something called functional reactive programming. In JavaScript, it's like observables or Rx.js or something like that. So here's kind of a model of an Elm program. You have some button that when you click the button, you want to toggle the color. So you have a function that takes in an observable, basically, and renders the UI. And then when the button gets clicked, you send an action on this observable. And then at the other end of the observable, there's this update function. There we go. This update function that receives the thing that came off the observable, and it receives the current state of the application. And then it applies that action to the state and returns a new state, kind of a new model. And then there's another observable hooked up to the output of this function that ends up calling your view function again. So you re-render your application with the new state of the model, and then our button turns red. And this is a thing you can do in JavaScript, and lots of people have done patterns like this in JavaScript. But the fact that it's built into Elm at both the language level and like the community level is pretty powerful, I think for two reasons. One, I think it's a good way to model applications. It's easy to build complex UI applications like this. But two, it eliminates this decision fatigue. There's no Elm fatigue, because you just do the way the language has been designed to work. And that's a pretty awesome thing. And I think it gets at this idea that this trade-off between constraints and freedom. So I think the JavaScript community values freedom. There are a million different ways to do everything. NPM has 80 bajillion libraries on it or whatever, and that's awesome. There's a ton of different choice in JavaScript. But that choice comes with a cost, because some of those things are better for some purposes than others, and you have to evaluate all that and figure out what's best for you. If you have more guidelines, more constraints, you don't have to worry about making all those choices. And if you trust the designers to have made good choices, then you get to focus on things that are specific to your problems, to your application domain. I drew this helpful diagram. If you, why are you laughing? Are you suggesting I'm not an artist? If you ever, yeah, this is like, what if someone tried to do code cartoons, but they couldn't draw? And this is the answer. They use Keynote to draw circles. So the green circle is the space of all possible programs, any sequence of characters that can be executed by any program or compiler or computer, whatever. There's some subset of that programs that are going to be good. And by good, I mean they'll be easier to modify. They'll be faster to update. They'll be less likely to have bugs. It'll be easier for new people to come in and learn them. And Elm has made design decisions that try and guide you towards some subset of good programs, where if you just do what's built into Elm, you'll be more likely to build good programs. And there's certainly a way to build bad programs in Elm. I have Elm code up on GitHub, and lots of it is bad. But Elm can guide you towards better programs. Constraints can guide you towards better design. This is like my thought leader slide, I guess. I don't know. Yeah, so I want to come back to that Dijkstra quote. A competent programmer is fully aware of the strictly limited size of their own skull. Before, we talked about this as not having to worry about how your values flow through your program, because the type system can help you with that. And I think this also applies at the higher level of language and framework constructs. If you don't have to worry about what's the framework du jour of like data modeling in React or something, you can focus on things that are specific to your problems, and you can solve those better than anyone else. And I think Elm frees you up to do that. Thanks, Dijkstra. That's him popping in to say hi. So there are some caveats. Everything has downsides. I don't want to give the impression that there's nothing, that Elm is perfect for everybody and there's nothing wrong with it. It has a smaller community. Server rendering's not quite there yet. If you don't use React Native, then maybe you'll be happy about this. There's no React Native in Elm. Elm does best when it can talk to JavaScript, and you can talk back to Elm from JavaScript, but it really does better the more of your application it controls. But I think most of these problems come down to the fact that it's still kind of early days for Elm. People are using it in production. Production ready is kind of a sliding scale depending on how bold you are and how much you're willing to commit to training and creating tools and stuff like that. So I would say for some people it's definitely production ready, but it has some issues. Actually, this morning somebody hooked up React Native to Elm, so I guess that one's crossed off. But I want to come back to my main thesis, which is that browser applications are growing. They're getting larger and more complex. The JavaScript community is smart and awesome, and they're coming up with great ideas and tooling to solve these problems. And I think Elm is what the JavaScript community is kind of evolving towards, but it's just built into the language. If you are interested in learning more about Elm, here's some resources. Elmlaying is the main website. There's a Slack channel. We did an episode talking to the creators. There are 2 really good talks. This is talking about how you do like side effects and talking to servers and stuff in Elm. And Let's Be Mainstream is a talk kind of about the philosophy behind Elm that I found pretty fascinating. Or you can just bug me on Twitter, and I will either answer your question or point you towards someone smarter who can answer your question instead. Thank you very much.